Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at I can say something you have never learned before, you never be taught in school, but by the end of this video you're going to learn something new. That's the objective of this channel, to promote the study of mathematics in schools and universities. So let's get started. Now we actually want to find the first derivative of a function. But what is this function? Y equal to what is this? 2. Then look at where the x is. Now guys, this function is different from y equal to x squared. Okay, I know that if I give you y equal to x squared, okay, to differentiate with respect to x the first time, you're just going to tell me that the y to x is simply 2x to the power 2 minus 1, which is 2x clearly. Now let's talk about something first before we come back to this. Let's talk about exponentiation. What is exponentiation? 4 to the power 3 or 4 to the power 4. What do? We have to multiply 4 times. So 4 times 4 times 4 times 4. Okay, that is simply 4 to the power 4. You can get the result. Now what about 5 to the power 2? You just have to multiply 5 how many times? You have to multiply 5 2 times, you get your result. So you see that in exponentiation we have that a to the power b is simply taking a and multiplying it with itself b times. So a times a till times a, how many times? B times. You see, okay, that is exponentiation. But now look at this bizarre thing here. Look at where the 2 is. Okay, look at where this 2 is. The 2 is here. Let me try to increase the size. The 2 is here and it's not making sense at all. But don't bother. As we proceed, it's going to start making sense to you. Okay, now if I tell you that, okay, what is let's say, let me begin with what we have. Let's say a, okay, and then we have b, exactly. So if I ask you, okay, what is this actually? Don't tell me that it is an atom in chemistry, please. No, this is mathematics. Don't tell me that it's an atom it's an atom b whose mass number is a and the atomic number is still to be found. No, please guys, what is this actually? This is simply equal to, follow up keenly. Now let me give you some little, let me give you a clue. Now you see 4 to the power 4, we are going this way. Okay, this is how we are going. It means that we take we actually taking 4 and we are multiplying it with itself 4 times. So that's the direction. Oh, this arrow is disturbing. Let me see if I put it here. Exactly. So 4 to the power 4, that is a direction of 4 to the power 4. Okay, so but this time around, in this case, rather, this is what we are doing. In this case, let me take a number because this a and b like that with this step. Let me say 2, okay, and then I put maybe 6. What do? I need to take 6 and I raise it to the power 6. It means that in the final result I need to have 6 2 times, but I'm carrying out an exponentiation. Okay, but now this 2 here will represent the number of 6 I'm going to have in my exponentiation. You see, here we have 6 and 6. There are 2 6, so the 2 represents the 2 6. Let's take another example. Let's say, okay, let's say 4, okay, and then maybe 7. What does it mean? It means that you have to take 7. In fact, in your exponentiation, 7 has to appear 4 times. So it's going to be 7 to the power 7. You proceed to the power 7. Okay, you're just getting it to the power 7. That's it. So this is what this means. Okay, and in this case, how do you work? You work from, you now work in this direction. This is how you work. Okay, because you begin by computing 7 to the power 7, you keep the answer. You now take 7 to the power that answer before you now take the final 7 to the result. But in this case, you're just going 4 to the power 4, which is simply multiplying 4 with itself 4 times. But in this case, this is how you work. You work from the last power up coming downwards. Okay, so now look at this. We have to find the derivative of this function. So first of all, we have to write that function as x to the power x perfectly, because this means that the number of x's that have to appear here is 2 in the exponentiation. There have to be 2 of them, so you have x and x. So how do we differentiate x to the power x? So we start by, okay, our y is equal to x to the power x. Now to always differentiate exponential functions, we take ln on both sides. So ln y is equal to ln x to the power x, which is x times the ln of x. Okay, now we perform implicit differentiation. So we differentiate the left hand side with respect to x, or with respect to y. If we differentiate the left hand side with respect to y, we just get 1 over y dy. We differentiate the right hand side with respect to x. What do we have? We keep x, we differentiate ln x, plus we now keep ln x and differentiate x. When you differentiate x, you have 1. Since we are differentiating with respect to x, we need to attach a dx to it. Okay, now the objective is to find dy by dx. Okay, so I'll just divide both sides by dx, and I multiply all through by y. I will get y times all of this. Remember that this x here divided by x will give you 1 plus ln x. That is it. Okay, but what is y? Our y is x to the power x into 1 plus ln x. So therefore we can say that y prime is equal to this. If we want to write it well, we are going to remove this part, okay, and then we write it like this perfectly. So we still have the function in it. So we have the 2 and the x exactly. So that is the derivative of this bizarre function. Now this is called exponentiation, while this is called tetration. So that's the name given to it. So this is called tetration and this is called exponentiation. So thank you guys for watching. See you in the next video. Hope you learned something new. Let me just give you some examples and you drop in the comment section your answer. So if you have learned tetration today, you have to tell me if you have understood by giving me the answer to this this exercise here. What is this equal to? Give your final response. Also, what is this equal to? Okay, in fact, let's do this one. Yes, let's do this one and we compare with the first exponentiation. So this one says it's 4 to the power 4, right? So you see that this 4 to the power 4, this quantity here is simply the same as this quantity, you see. But you see here we have to, in fact, let's do this quantity. I'm going to give you another exercise. This is 4 to the power what? To the power 4, then to another 4, right? So we work from top. So this 4 to the power 4 here, okay, is simply this 4 to the power 4 here is the exponentiation that we have here. So it's simply multiplying 4 with itself 4 times. That's what we have. We multiply and have the answer. If the answer is a, then 4 to the power a is now multiplying 4 a times. You see that here is 16 times 16, 256. So this will just give you 4 to the power 256. Guys, this is too big. It means you have to multiply 4 with itself 256 times. Okay, so you see the difference between. But if I tell you that, okay, what is 4 cubed? 4 cubed is simply just 4 times 4 times 4, 64. You see the difference between the tetration and the exponentiation, the difference between the result. So you see that this number is too big and in fact it's too big than this other number. So guys, back to your exercise. What is this? So please tell me in the comment section. Let me be sure that you've understood and you've actually learned something new. 5 2. What is this equal to? Next one, 3 3. What is this equal to? So guys, tell me the answers to these two exercises in the comment section. Make sure you like the video, share the video with your friends, subscribe to the channel, and turn on your notifications so that whenever I upload other videos, you always be notified to come and watch. Stay tuned, stay blessed, and see you in the next video.